Hey guys, this is Bonifaci. We're going to talk a little bit about a diagram that you need to draw. Okay. Now, I've asked you kind of print one if you could, and if you can't, we're going to draw it here. Okay. You start by putting moles in the middle. Okay. And you can go to and from moles to different places, and they'll actually a third area down below we'll do later, but that's not for like a week or two. So moles can go to a bunch of places. The first one over here is particles, and moles can move to and from particles. Okay? So you can convert two particles and from particles back to moles. And our particles can be the number of atoms, or the number of molecules, or the number of because because moles is a grouping, right? It's like dozen, right? Like you could have 4 dozen ducks, you could have 4 dozen donuts, you could have 4 mole ducks or 4 mole donuts, right? But a mole is a lot more because one mole is, and this is the equivalency statement. 1 mole is 6.0222 times 10^3 particles, and that could be this year could be atoms or molecules or whatever else. Over here on the other side, okay, you'll see we went to mass and grams. So if we want to figure out grams, right, we can go to and from moles with grams by using the periodic table. Okay. And the way you accomplish that is 1 mole is equal to the molar mass, and the molar mass is the grams of the periodic table. So for example, 1 mole of iron is equal to 55.84 grams, and 1 mole of oxygen is about 16 grams. So it varies based on what it is. The final thing that I want you to have on it so far is this part over here. This is more extra credit, but it might show up and maybe you won't get it. So you can go from the base unit, which is grams, all these different prefixes. So this is things like milligrams or kilograms or nanograms or anything else like that, right? So, and the way you do it is you look up whatever the prefix unit is, milli or killa or nano, and that's 10 to the x, and you have to know what that x is based on looking it up. And grams equals just one of whatever these prefix units are. And that's how you can convert back and forth from those. Okay. We're going to use this kind of cheat sheet going forward. I'm going to go ahead and screen share, and then we're going to start working some problems together, and we'll use kind of our cheat sheet to solve those, okay? So let me go ahead and start the presentation here. So moles to particles, like you're going to see here, mass to particles, is a two-step conversion, okay? And you don't need to write these notes. Well, it's going to combine the things we see here. You combine the moles to particles with the moles to mass. So it's a two-step one, okay? Now, whenever you see a problem like this, I often go to the map. The map is going to be a go-to thing. So it's going to ask how many atoms are in 3.92 grams of hydrogen, okay? So I look at my map and I'm like, where are atoms on my map? Oh, atoms are up here. And I'm going to go to grams. Grams are over here. So it's going to be a two-step problem, 1, 2, okay? So how many atoms? Okay, so I start with 3.92 grams, 3.92 grams of hydrogen. Just your knowledge that hydrogen is H, okay? If you solve as H2, it'll work out too, okay? But we'll deal with that later, okay? Grams. Now, you can't go straight from grams to atoms. That's not possible. But you can go from grams to moles. So that's what we're going to do. We'll get rid of grams hydrogen and go to moles hydrogen, okay? And right here, it's the mole is almost always a 1. And grams hydrogen is, how many sig figs do we need? We need 3 sig figs. So I would round it off. I wanted 3 to 1.0. And then I could go 1 if I wanted 3 sig figs, or I can go 0.8. If you recall, you should have at least 3, okay? So in that way. So there's our first step there, and grams hydrogen to be canceled out, yay. So in that way. Now, moving on to the next one here, we now have moles hydrogen. We're going to go ahead and go on to the next step. So we're going to go from moles to atoms, okay? So if we're going to go atoms hydrogen, okay, we have to get rid of moles hydrogen, and we have to go to atoms hydrogen. And using this sheet here, I noticed that I used this equivalency statement here. 1 mole, like it says right here, is equal to 6.022 times 10 to the 23rd atoms hydrogen. So now it's a matter of entering it in my calculator. Okay, so I go 3.92 and I divide it by 1.008. Okay, and then I multiply it, and I'll teach you guys the shortcut if you haven't learned the shortcut yet. I multiply it times 6.022, and then I enter my exponent in here as 23. And we'll see what the magic device says. It says my answer here is, so it looks like I need 3 sig figs. So it's longer, but I'm going to round it off to 2.34 times 10. My exponent tells me is 24. And I have to make sure it's atoms hydrogen like that. And that would be my answer. So we'll go ahead and do another practice problem like that. So here we go. Now, 1 second, I need to wipe it clean here. Okay. We'll go ahead and do we'll do this top one. That'll be good enough. We'll just do one more in this way and then we'll do the other way. Okay. So again, we start here with atoms, which are, so you'll notice here we start atoms. No, actually, no, we don't. We start with grams. We start with grams here, and we want to get to atoms. So it's the same direction. So grams to atoms. So, and I know this because where my number is. My number is a 4.3 times 10 to the 2nd grams krypton. Okay. So I start with grams krypton, and I can go to, grams krypton's over here. I start with grams krypton, and I go to moles. Okay. So grams krypton's here, and I want to go to moles krypton. Whenever it's grams and moles, it looks like I use 1 mole to go to the molar mass. So I look at krypton's over here, and it looks like how many sig figs? I need 2. So I will do 83.8. I'll keep an extra one. 83.8 at this point. Okay. So that gets rid of grams krypton. Now we are stuck with moles krypton. Let's get rid of that. So we'll divide moles krypton, and we'll go to our final step here, atoms krypton. Okay. And in this case here, moles to atoms. We use this one. 1 mole is equal to 6.022 times 10 to the 23rd. Okay. Now it's a matter of just entering my calculator again. Okay. So 4.3, I entered the exponent 2 for 10 to the 2. I'm going to divide that number by 83.8. Is that right? For krypton? Yep, that's right. And then I'm going to multiply it because it's on top by the 6.022 E23. And that should give me my magical answer. Looks like I can go into 2 sig figs. So my answer should be 3, and then it goes 3.09, but I'm going to round that to 3.1. And then it's going to be times 10. The exponent is 24 again. Okay. And okay, that makes logical sense. So 3.1 times 10, 24, and that's atoms krypton. Okay, that's what I have. So we're gonna go ahead and do some the other way here, just so you kind of see how that works. Okay. So this is the same thing, just the other way around. Notice this time I give you the number in atoms. Give you the number in atoms, right? And I'll ask about the mass. Okay, so we're going this direction now. So we'll start over here with 4.53 times 10 to the 25th atoms of helium. Okay. We're going to get rid of atoms helium, and we'll go to moles helium, which is the first step. Atoms to moles, okay? And that's 1 here and 6.022 times 10 to the 23rd right there. Okay, so that gets us to moles, okay, because we get rid of atoms there. Now we have moles, we want to go to mass. So we have to go to the next step here. Moles helium, and get rid of going to grams helium. So moles cancel moles out, right? When I look up helium, I find it over here in the upper right corner. It looks like it's 4 point, how many sig figs I need? 4.00 actually. So it rounds off nice and even. 4.00. You can keep going if you want. It doesn't, yeah. So, okay, so now it's a matter of entering in the calculator. So 4.53, and then I have to do the exponent to the 25th. I'm going to divide that by this number in the bottom here, which is 6.022 exponent 23. Okay, and then I'm going to multiply it by 4, and I'm going to enter, and I'm going to get 300. It looks like 300, and then it goes 0.9 if I round up. So it looks like I only know 3 sig figs though. So in that case, it's going to round up to 301 for 3 sig figs. And then if I put in scientific notation, 3.01 times 10 to the, I moved it 1 spot, 2 spots. So I moved it 2 spots, it's to be a positive 2, a negative 2, but 300 is a bigger number, so we have positive 2. And it is atom, no, I want a mass. So it's grams helium. So it's always worth going back and checking. Okay. We'll do one more practice one together. Okay. Let me go ahead and do this one here. I don't want to do the one of kilograms, so we'll do that maybe another day if people want to. So let's do this one right here. We'll do atoms again to mass. So just like the other one. So we'll start with atoms, we'll go to moles, and then we'll go to mass. So it's good to use the map. Okay, the map is easier to keep it straight. Okay, so 5.2 times 10 to the 2 atoms argon. Okay, and then after atoms argon, look at my map, I can go from atoms argon to moles. So I get rid of atoms argon, I go to moles argon. Okay, so atoms cancel out, right? Moles to atoms, would I'd use this equivalency statement. So it looks like 1 goes in front of moles, and in front of atoms goes the giant number, 6.022 times 10 to the 23rd atoms. Okay. So now I'm at moles argon. So I need to get rid of moles argon. And I want to go to mass over here. And mass is in grams. So it looks like I want grams argon. And 1 mole, so 1 mole is equal to the molar mass of argon. And argon is 39.9. So 2 sig figs. Well, I'll keep 3 this time. So you should keep again at least the number it has. So you should delete, if you did just 2, it should be 40 though, because you'd round up. But I'll do 39.9, which will work out. So okay, I entered my calculator here. It looks like it is okay. I will do 5.2. I'll do my exponent button, the second, and then I'll divide it by 6.022, again with the exponent, and then I'll multiply it times 39.9. Hopefully I entered that all correctly. And it says my answer, and this seems somewhat logical, is so 2 sig figs, right? So I should round it to 3.4. And let's see, it says the negative 20, so times 10 to the negative 20. And this is grams argon. Yeah, that makes logical sense. Very few atoms would lead to very few grams. Okay. So hopefully that makes sense. So just to be clear, you need to write down the practice problems. Hopefully you did that. I'll put the notes on the webpage right there. And have the map down, and having the map and the practice problems here will give you your points. So just go ahead and submit a picture of that. So thanks.